All right, so looking at section B here of chapter 1, so we'll just kind of go down the list here for the problems that we're doing for the assignment. So we get given a function right here. Again, some normal notation that you would see with functions like this would be this statement. So it just says that x is an element of the real number system, which is obviously going to always be true. So this really isn't something you worry too much about. They also say that x is not -4, which we already know because that would create a zero denominator, so that's something we can't have. So that's actually the first part. That's where the vertical asymptote comes from. The vertical asymptote are the x's that we cannot use. So in this case, x cannot equal -4, so that's where you get the vertical asymptote from. So for this guy, x equaling -4 is the equation of the line where the vertical asymptote is. And remember, an asymptote is simply it's an area on the graph where your graph does not touch or cross. And so that gives us the vertical asymptote. Right after that, the horizontal asymptote. For rational functions like this, a rational function is anytime you have a variable in the denominator. So for rational functions, we can simply do, when you have x's like this, where you have an x to the first and an x to the first, all we have to do is do the coefficient divided by the coefficient. So 3 divided by 1 gives us the horizontal asymptote. So y equals 3 is the horizontal asymptote. The other way to look at that is if the top exponent is bigger than the bottom exponent, then that means there is no horizontal asymptote. If the top one is smaller than the bottom exponent, so like let's just say that was x over x squared, or if there is no x on top but there is an x on bottom, then it's always at y equals 0. So those are kind of the three options that you run into for these. So we have our two asymptotes. So the coordinate of point P, which is where those two asymptotes would intersect, well, we just combine the numbers. So at -4, 3 is where those 2 points would intersect. And so we're getting kind of the initial stages of our graph here. So as far as just a rough sketch goes, we know that at -4, we have our vertical asymptote, where y equals 3 is our horizontal asymptote. So we're getting the boundary lines of our graph. So I know that for the rest of the graph, right, I could either get part of it here, or here, or here, or here. So those are kind of the four areas where we might see the actual graph itself. We've kind of established the boundaries for the graph. So for the graph that they're talking about here, if we were going to sketch it, while showing the asymptotes by the dotted lines, which I've already done, and we already showed that at point P is where they intersect. That would be at -4, 3. So as far as sketching the graphs, two ways we can do this. One is always on a calculator. If it's a portion of a test where the calculator is available, we do run into, because of on the IB test, part of it is calculator and part of it is no calculator. You know, we do want to be able to handle certain things with and without a calculator. So we can do the sketch of the graph on the calculator, and I'll show that in a second. We could also do it by hand if you wanted to kind of use an old school method of just plugging in some numbers. Since I have a boundary line right here at -4, I could just sub in -3, -2, -1 and get a few points and connect the dots for that curve. I could use -5, -6, and -7 to get a few points on the other curve and connect those dots. So that would be doable by hand for sure. If it's something we're able to use the calculator on, then we would just go to the y equals, and I would just graph the function. So you're seeing the function right there. So I'm just put it into my calculator under y equals. Remember to always put your denominator in parentheses. That does matter. So I always put the top and bottom in parentheses just to take a safe approach on these. But anyway, also one other thing that you'll kind of get used to checking is the window. So right here, if I hit window, this is going to show me what my calculator what part of the graph I'm going to see on the calculator. So the typical settings go from -10 to 10 on both axes. You can adjust those if you ever need to see further to the left or further to the right or lower or higher. You can always adjust those numbers to see whatever more you need to see on the graph. There's also a zoom feature, so you can zoom in and out to see more or less of the graph as well. But anyway, I'm going to hit graph, and so here's what would come up in my window settings, and that's enough for us to get a sketch of the graph. You can see the boundary line that goes right here through x equals -4. You can also see the asymptote right here through y equals 3. And so we'll just kind of sketch the curves within those areas. If I would have just plugged in some numbers, I would have gotten some numbers within those areas as well, but we're just doing kind of a general sketch here for what that graph would look like. All right, moving on to part C. So now we have a line, they're calling it line L, has the equation 4x plus 3, and it is tangent to our graph that we already have drawn. Tangent just means they have a point in common. So they're going to have a common point of intersection. They're calling that point T. So that's be the point that we need to find. So for this one, all we're going to need to do is set this equation equal to this equation so that we can solve for x. So if I did my 3x minus 4 over x plus 4 is equal to 4x plus 3. And so we're just going to solve that equation. So I'm going to multiply x plus 4 over to the right. So that's going to give us a little FOIL or distribution to do on that side of the equation. So here's the setup that we're looking at. So on the left side, we just have the 3x minus 4. And on the right side, if we distribute, so we got the 4x squared, we got 16x plus 3x, which is 19x, plus 12. So here's the equation that we're looking at so far, and because we're solving a quadratic, I'm just going to subtract the 3x and add the 4 over to the right so that it equals 0. So minus 3x now gives me 16x, add the 4, I have 16. You may recognize that this is a perfect square, but you can turn to any quadratic solving method for this. If you want to factor, if you want to use the quadratic formula, really just whatever it takes to solve at this point. So for me, I would recognize that my factors are identical factors. They're both 2x plus 4. I could have taken a little bit of a shortcut. 4 goes into all of these, so I could have just divided the whole thing by 4, and that would have given me a simpler quadratic to work with. So if you recognize that shortcut, that's a good way to go as well. But anyway, if I set my factors equal to 0, so 2x plus 4 equals 0, and if I solve that, I'm going to see that x is -2. And there's only one solution here because my factors were identical, so there's only one point of tangency. We now know the x coordinate for that point of tangency is where x equals -2. So all I would have to do to get a y coordinate is plug that back in. Now for this one, I should be able to plug that into either equation because this is a common point of tangency. So I would just pick the easy equation to sub this into. So if I plug a -2 in right there, then I'm looking at -8 plus 3, which is -5. So there's my y coordinate. So we have just found point T, which is -2, -5. So let's see, -2, -5 would have put us somewhere down here. So that just means my sketch was maybe a little too rough to begin with here. I could have gone for a little more accuracy on that. So at -2, -5, call it right there. So the original graph was really doing something like this. So there's point T. And so we get this tangent line that would do something like this. So it's tangent to our curve at point T, and we know that is at -2, -5. All right. You could see up here that I could do another line that is parallel to that line and would have a new point of tangency, but it would run parallel to this tangent line, and that's what the next part of the question is asking about. So now it says another line, line M, is parallel to the line that I just drew and is also tangent to the graph, and this one is now at point S where x equals -6. So if I look at the drawing, so this was line L, and so I have another tangent line that is parallel to this line, so it's going to hit somewhere up here. So they're calling this one line S, and we know that it's parallel, or sorry, line M, and it's parallel to line L, and its point of tangency they're calling point S. And they already told us the x coordinate is at -6, and so all I would have to do is plug -6 back into the original function in order to get a y coordinate to go with them. Keep in mind this is a new line here. This is not line L, so I can't plug it back into that equation. It's intersecting with this function, so I'd have to plug in my -6 into this function in order to get that point. And this is always something you could do on a calculator. Since this is already graphed, if I just go to my calculator and go to the graph, if I go under Calc and choose Value, if I just plug in -6 and hit Enter, you can see on my screen that it tells me that y is 11 at that point. So there's my y coordinate. So that's something we could do on a calculator. I could also, again, just plug -6 back in for x right here, and I should also get 11 to complete the coordinates for point S. So jumping back onto our page right here, so S we just figured out was at -6, 11, so the y coordinate was 11. One thing you really have to be careful on whenever you're doing a test question is make sure that you specifically answer the question. If I wrote my answer like this, technically I could be docked points for that because it didn't ask me for the ordered pair, it only said the y coordinate. So technically for this answer I should only list 11 as my answer and not the complete ordered pair, because that's not really the way the question was worded. So always read your test questions very carefully. They do give you some pretty specific ways of writing answers, so it's important that you always check and do exactly what the question is asking you. On this part, so find the equation of line M. Well, we now know a point on that line. We know the slope because it's parallel to line L. So since line L had a slope of 4, that means our slope would also be 4. By the way, you're going to get used to the word gradient instead of the word slope. IB uses the word gradient for slope, but for now, we do know that our slope is 4. We have a point on our line, so the equation, we just use the point slope formula for this, which is in your formula packet. So I'm looking at y minus y over x minus x equals my slope. Typically we're going to write these answers in slope-intercept form where we get y by itself, but this is another case where you could easily get a test question that gives you another way of how to write this answer. So always be reading the test directions carefully on how to write these answers. I'm going to multiply the x plus 6 over to the right, so that tells me y minus 11. Oops. So that tells me y minus 11 is equal to 4 times x plus 6. So I'm going to distribute. I'm going to add 11 to the right. And that would be my equation for line M. All right, for the last part of this question, it says show that P is the midpoint of TS. We do have a midpoint formula. And really all the midpoint formula is an average of the two endpoints. So if I took point T and point S and found their average, So I'm going to add the x's and divide by 2, add the y's and divide by 2. I should get the midpoint, which they're saying is point P. So we got to show what that is. So if I took point T, slide down a little bit so you can see this. So for point T, we had the coordinates for this one of -2, -5. And we know that point S is at -611. And so if I just do the midpoint formula, which is x plus x divided by 2, and y plus y divided by 2, a little cleanup on that, so -8/2 is -4, and 6/2 is 3, and we are showing that that is also point P. All right, the same coordinates that we got earlier on in the problem for the coordinates of point P. All right, moving on to question 2. So they're again starting us out with some other function. Here's just some common notation. X is an element of the real number system, and it cannot equal 3 because of what we see right here. This really is not going to affect what we do for this problem. That's just kind of standard notation that they're showing for that function. So show that it could be expressed in this form. If you notice, this is simply one big function, which means I want to add these two things together. And so I'm going to need some common denominators in order to make that happen. So right now, think of this as x plus 4/1. So if I were to multiply this fraction by x minus 3 over x minus 3, I would be creating a common denominator for those. So let me write that down below. So we're going to do x plus 4 times x minus 3 over 1 times x minus 3. And so I'm just going to start out with that part of the problem, but if I do a little FOIL on the top right there, I'm looking at x squared plus x minus 12 over x minus 3. And now I'm going to bring down the other fraction that we had. So it looks something like this. Now that they have common denominators, I can combine like terms. So for the numerators, I'm going to do now the -12 minus 8, which is -20, over x minus 3. And there we go. So we showed that it can be expressed in that form. One of the common IB wordings of questions is the show question, where they basically give you the answer but show you how to get it. The reason they do that is because you need that answer to do the rest of the problem. So it's like if they didn't give us the answer and you get part A wrong, the rest of the problem is wrong and you wouldn't even be able to do the rest of the problem. So it's kind of their way of making you still do it, but making sure that you get the answer right so that you can move on and do the rest of the problem correctly. So that's the show question. You do have to show the work for stuff like that in order to get credit for those. So to now show that it could be expressed in this form. All right, so next part of the question, they're now saying show that it could be expressed in that form, which is just factored form. So if we factor this, so two numbers that would multiply to be -20, that would add to be +1, would be numbers like -4 and +5. So if I write down the factors, so those would be my factors, and we could write it as x minus 4, but sometimes just with IB stuff, you really want to be careful. If they say show that it can look like this, you got to show that it looks like that. So I'm only putting the plus sign because they had a plus sign, so it's always good to be careful that you're following like real specific directions on these. So you can see based on that one of our values is -4, the other value is 5. Based on this statement right here, they're telling me that A is greater than B, so A must be 5 and B must be -4 for that statement to be true. So find the vertical asymptote, pretty similar to question number 1. That comes from this statement right here. If x cannot equal 3, then the equation of the vertical asymptote is x equals 3. So that's all we have to do for that one. the coordinates of the intersections of the graph with the axes. Anytime your graph is on an axis, there's a 0. If you are on the y-axis, that's when x is 0. And if you are on the x-axis, that's when y is 0. And so these are just about plugging in zeros to get the intersections with the axes, or we could sometimes call these the x-intercepts and the y-intercept. So I'm just going to give you some quick verbal explanation on this, but if I want the y-intercept, I would plug in a 0 for my x's and simplify. And if I want the x-intercept, I just set the whole thing equal to 0 and solve from there. If this whole equation equals 0, when I multiply the x minus 3 over to the right, it's just going to still be 0. So all I have to do is set this and this factor equal to 0 and solve. So negative 5 and positive 4 are going to be the two x-intercepts that we would find. So as far as just sketching the graphs, again, this is a pretty similar repeating of question number 1, so I'm just going to explain it really quick. But you could either use a calculator if it's a test question where a calculator is available, and I showed how to do that on question 1. You could also do some of this by hand. We now know a decent amount of information. We know the intercepts, so I would plot those points. We know the asymptote, so I would draw that line and show where that asymptote is at. So just based on it from there, we could just do some curve sketching either from the calculator, or I could just sub in a few numbers by hand and find a few specific points and create my curves that way. So there's always kind of the older method of just plugging in some numbers if you need to do it that way for a few of those questions. So last part on this question, on part C, draw the line y equals 5 on the same diagram. So that would just be a horizontal line through 5 on the y-axis on that same diagram. So the coordinates of the intersections of that graph, two ways to do this. The way that you would do it by hand is you just set the whole equation equal to 5 and solve. And so that's one way of doing that. The other way is within the calculator. So I'll show you that here real quick. So I went into my calculator and I graphed the original function that came out to look like this. Because I'm setting the whole thing equal to 5, if you just go back into y equals, graph a second graph for y equals 5. So hit graph. You can see there are 2 points of intersection. So all I have to do is right here go under calc. So second calc, choose intersect. There's 2 of these, so just put the cursor closest to the one that you want to find first. You hit enter, 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 and there's your first point of intersection. Go back under calc, choose intersect again, bring your cursor over to the other guy. So I'm just scrolling over to the right, there it is, and hit enter, 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 and there's my second point of intersection. So that's an easy calculator way of doing something like that. And so as far as the solutions for this one, that's what my solutions would be those points that we just found on the calculator. So last thing here, do keep in mind that for the solutions of this final equation that we solved right here, if you look at that setup, you'll notice there's only an x in that equation. So we would not list the full ordered pairs as our solution to that equation. We would only list the x coordinates since there is no y value in that equation. That is different than when they said the coordinates of the intersections, because now they're asking for the ordered pairs, so now you do list the full coordinates x and y. But on this one, in solving this equation, we would only list the x values as our solutions. All right, last one here on the B worksheet. So they're starting us out with another function right here, a cubic function. They tell us we have a minimum at point A and a maximum at point B, and they give us some x coordinates for those. First part asks us to find the y coordinates. If you were not using a calculator, we would simply take the x value and sub it in for x in order to get a y value. And so that's easily something we could do by hand. If it's something we're able to use a calculator on, then here's how we would do that on the calculator. So I would go to y equals, I would plug in the function and then graph it. Now on this one I had to toy with my window settings a little bit in order to get it all on my screen. So after trying a few different things, these are the numbers I came up with in case you're following along. So there that is on my graph. Once you have the graph, if I'm going to sub in a value like -2, I can do that under calc. So if I just hit second calc, choose value, which is the first option. So if I want to plug in -2, just hit enter, and they give me a y coordinate to go with that. So I got -28 for that guy. And then I could do the same thing where I sub in a 4. So if I go back into calc, choose value, plug in a 4, and hit enter. So 480 is the other guy. So they asked us for y coordinates. So again, here's one where you really need to read carefully. At point A, I only list the y coordinate. So for point A, we figured out that y was -28. And at point B, we would say that y equaled 80. Again, you got to read careful on directions on a test. If it only says list the y coordinate, then you only list the y coordinate. If you wrote this down as an ordered pair, like -2, -28, you can be marked down for that because that's not specifically what the directions ask for. So you really always got to read careful and answer questions exactly the way that it's stated. So write down the coordinates of the image. Okay, so for this one, it would help to see the original coordinates first. So for point A, that was the one at -2, -28. And so if we're going to reflect that across the x-axis, so if I'm going to reflect that across the x-axis, well, notice I'm just going up, so it's going to affect the y coordinate. So I was at -2, -28. I'm now going to be at -2, +28. So it's just going to change the sign of my y coordinate. Just like this one, when I reflect across the y-axis, is going to change the sign of the x coordinate. So for point B, if I reflect across the y-axis and put it over here, notice I am moving to the left, so it's just going to change the sign of my x coordinate when I do that. So the original B was at 480 and is now moving to -480. So it's just changing the sign of the x coordinate for that one. If we were to translate it according to that statement right there, that's in vector form. So for that one, remember the x is on top and the y value is on bottom. So this one tells me I want to add 6 to my x, and I want to subtract 4 from my y. So I'm doing this for point A. So if I look right here, and this one's taking me back to the original because it referred to the image of A. So I'm going back to the coordinates for the original A value. And I'm going to add 6 to the x and subtract 4 from the y. So if I did -2 plus 6, that would put me at 4. And if I subtract 4 from the y, that puts me down at -32. All right, and then for the last part here, so the image of B, after I reflect across the line y equals x, so you can kind of see this visually. If I were to draw the line y equals x, it would do something like this right here. Anytime you reflect across the line y equals x, look at the statement. If y equals x, that means I can trade places with them. So anytime you reflect across that line, it's just a coordinate swap. So those two guys would just trade places. So if I reflect across the line y equals x, so for B, B was at 480, so if I trade places, it would become 84. So there's the reflection across y equals x. And if I do a vertical stretch, so if I'm affecting the vertical component of this, then it's going to affect the y value. So I'm going to multiply my y value by 3/2. So my 80 wouldn't change. But if I did 4 times 3/2, let's see, it would be 6. So that's going to be the ending result on that one.